Okay, hello everyone. Can you hear me? Okay, so my name is Haoyi, and this lightning talk is going to be about safe, concise, performant code using the Scala Programming Language. So this is going to be a kind of a different talk from many of the others you see at this conference. It's not so much about data and AI specifically, but it's about the Scala language, which is a language that Apache Spark implemented in, among other projects, and why it's such an interesting language to look at and use. So yeah, this is the agenda for today. Some introductions, why the Scala language is interesting, some comparisons versus other languages, and the conclusion. So I've been using Scala since 2012. I've done a lot of Scala open source work, libraries, tools. I worked at Databricks and Dropbox before this, and I'm the author of the book, Hands-on Scala Programming. So about the Scala language. So first released in 2004, it's a pretty niche language. Like you hear about Apache Spark being written in Scala, you hear about Twitter being written in Scala, but it's kind of the exception that proves the rule in that like these are the ones that you hear about and like almost no one else is written in Scala. There are some others, right? There's like, there's Apple has some code in Scala, Disney streaming is all in Scala. But again, these are the exceptions, and most code in the world is not in Scala. Like for example, on the Red Monk rankings, Scala's 15th rather than 3rd like a language like Java, or 1st like a language like Python or JavaScript. It's like a hybrid language, so in many ways, it combines object-oriented and functional programming. So you have objects like new and interfaces. You also have lambdas and structs and pattern matching. You get some Java-like performance and Python-like conciseness. And in general, it's a language that is a compiled language, but kind of feels like a dynamic language to use. And we'll see what that means later. Lastly, it's a hosted language, so it doesn't have its own Scala runtime, so to speak. But it runs on the JVM. You can use your Java library, Java tools. You can use YorkKit. You can use Guava. You can use IntelliJ, Eclipse, all the standard Java stuff. And any of your own code can be used if you have existing Java code. It also has a JavaScript backend, which is quite interesting, but I won't have too much time to talk about that. But you can run Scala in the browser, just like you can run TypeScript or other JavaScript languages. So at a glance, Scala looks something like this. So it looks very similar to many other modern languages, right? You have local variables, you have collections, you have string literals. Like most modern languages, you have some helper functions like group by, .count. So you don't need to spend a lot of time like messing around with for loops and while loops and trying to count things yourself. You do have for loops. You can loop over tuples, or you can in most other modern languages. You have string interpolation. So far, nothing special, right? Like this stuff is Kotlin, Swift, modern Java 23, Python by 3.10, 3.12. They all have these language features. So what's interesting about Scala? So maybe the one way I frame this is most traditional languages trade off between two axes. You have your performance and scalability axis, and you have your like conciseness and productivity axis. And the world looks something like what you see on your right here. So you have your C++, Go, and Java, very performance scalable, kind of annoying to write and read even. You have your Python, Ruby, Bash, and JavaScript to some extent, much more concise and productive, but also kind of slow and clunky and not really scalable. Like the old Twitter fail whales, and everyone kind of knows that these languages are great for getting started, but not great when you've become big. And then you have some other languages, maybe like SQL or HTML, that don't really fit within this spectrum, but you have to write anyway day to day. So some newer languages like Kotlin and Swift try to break this dichotomy. They start off, Swift starts off from a C++ background, Kotlin starts off from a Java background, and both languages ask, if we trade off a bit of our performance, can we get a lot of conciseness and productivity back, right? So like Kotlin is now standard for Android, everyone writes Kotlin, Swift is standard for iOS, everyone writes Swift. And they do fall like kind of in this bucket here, like neither in the compiled language bucket nor in the scripting language bucket. Scala is even more to that angle. So it is in many ways just as concise and productive as a scripting language like Python or Ruby. But on the other hand, it's also just as performant and safe, some ways even more safe than languages like Go or Java or Kotlin or Swift. And this has a lot of benefits, one of which is that it really lets you replace code written in many other languages. Like most of you will have code bases with like 5 different languages, 7 different languages in them. And you can, in fact, have code bases with 2 or 3 languages in them if one of them is in Scala and can be used as a general purpose language. So let's look at some comparisons, what Scala is like compared to some other languages, right? Like, so Scala versus Java to begin with. On the left-hand side is what Scala, making HTTP requests in Scala can look like, and the right-hand side is what making HTTP requests in Java looks like. I elided the standard public static void main string args in both examples, just to focus on the code itself. And the right side is modern Java. Like modern Java, as you all know, Java 23, is a lot more concise and productive than Java 5 or Java 8 was 10 years ago, right? Like you have your type inference with vars. You have your Java net.http client. You're no longer using Java net HTTP URL connection. And you have a whole bunch of kind of modern niceties that Java provides nowadays. But even so, you compare modern Java, which is already like 2 or 3x more concise than it used to be, versus like modern Scala. And it's a very big difference in just how concise your code is. In fact, the code on the left looks exactly like Python, except for this like val you see here. Like, if you take away the val keyword, it's a perfectly valid Python code using the request library. And the Scala request library is just modeled off of that. It looks about the same. And so this is just one like small snippet. As the snippet grows, it gets the difference doesn't shrink, but instead gets even more extreme. So here is this, if you want to make the HTTP request and you want to write it to a file. So this is not exactly rocket science, right? You want to take the HTTP request and store it somewhere. Again, the Java code is not terribly complicated, but it is very long. And if you want to make the HTTP request, write it to a file, and wrap it in a main method I can call from the command line. Again, this is a very simple thing that you might want to do. And with Scala, it's basically rewrite the main method with the types and method and parameters it takes, and you're done. And in Java, you spend all this time messing around with arg parse for j, creating your argument parser, adding arguments to it, calling parse, extracting the arguments that you've already parsed. Like, why do I need to do this again? And then feeding it through this Java HTTP client before feeding it through your Java utils, paths, and files in order to get what you want. So I guess one thing that should be clear here is that it's not, even though Scala in some ways is just like convenience and helper methods compared to Java, like this request.get you see here, this os.write, this main annotation, none of this is like magic, right? They're just helper methods. But at some point, the helper methods do result in a qualitative change in how you can work with the code. Like how fast you can prototype, how fast you can try something out, show something to your boss, how fast you can read code and refactor and debug when something goes wrong. Like how many things can go wrong in the code on the left versus how many things could potentially go wrong in the code on the right. It really makes a very big difference in how productive the language is. And that's why people say like, Scala feels like a dynamic language. It doesn't feel like writing Java or C or C# or C++ or even Go. It feels like writing Python or Ruby, and this is what that means. So if Scala looks like writing Python, why not just write Python, right? Like everyone knows Python. We all learned Python in school. I learned Python in college. It's a great language. Maybe one of the biggest reasons that you might not want to write Python is the performance. So Python's gotten a lot better in many ways. Like Python has static typing nowadays. Python's all sorts of better build tools. Productivity is a huge ecosystem. The performance of Python code still honestly sucks. So this is a kind of a synthetic benchmark here, right? No one actually writes Fibonacci functions in their code. But you will write other functions. You write parsers, you'll write business logic, you'll write your own graph traversal algorithms, whatever, in order to do whatever business stuff you need to do. And Python's always going to be about 40 times slower than Java or Scala or any other compiled language. And maybe Python's gotten a bit faster, like 10% faster in Python 3.12. So now it's only 37 times faster or 36 times faster to write in Python or in Scala or Java. And this has a whole bunch of follow-on things, right? Like when your code is fast, you don't need to deal with caching. You might not need to deal with incremental computation. You might not need to deal with parallelism. You might not need to deal with micro-optimization. A whole bunch of like auxiliary complexity just disappears when the code is just fast enough to run it again each time. And when you're writing in Python, that's not what you get. But when you work in Java or in Scala, that is something you can benefit from. Another thing that Python is still struggling with is parallelism. In Scala, it's very easy to just say, hey, run this in a future block, they call it, which is runs asynchronously on a separate thread. I want to run 2, I want to run 4, I want to run 8 Fibonacci functions in parallel. Just do it, and you can await the result later. Again, not rocket science. This is very straightforward, but it's worth noting what we are not looking at here, right? We're not looking at locks. We're not looking at threads. We're not looking at sub-processes and sub-process pools and serializing our data and serializing our function calls to pass across the sub-process boundaries. We're not looking at shared memory maps in order to share the data back and forth. You just chuck your thing into a future, wait for it later, and that's your parallelism. And it scales very well. Like, you look at this graph on the right. I just benchmarked this last night on my laptop. You basically get linear scaling up until how many cores you have on your machine. There's some other properties of Scala that makes this nicer. For example, the fact that you don't generally mutate stuff as much as in Java or C++ means you don't need to worry about race conditions as much. These futures return their result rather than like storing to some variable, which means that you don't need to worry about like people stomping over each other's results. But in general, it means that Scala is very easy to do parallelism, which is something that in Python is like famously difficult even after 20, 30 years of the language's lifetime. So one interesting use case I found in my previous jobs at Databricks, Dropbox, and elsewhere is Scala versus Bash. So Scala is not more concise than Bash. I show it's more concise than Java. It's about as concise as Python. It's definitely not more concise than Bash. But in some ways, that could be argued to be a good thing. Like, you compare this, small snippet of logic in Scala versus Bash. The Bash code is definitely more concise. But if you come back, 6 months later, and you wonder, what on earth does this curly brackets and plus do? Like, when do I need it? When do I not need this curly brackets and plus? That's actually quite a big problem, right? Like, you can kind of guess what the Bash does, but it's not obvious, and it's also very easy to get wrong. You might type this out later, you forget the plus, and something weird happens. You're not sure why. Maybe it doesn't work. Maybe things break when files have a white space in their name. That kind of obscure edge case that's very common in Bash and very easy to get wrong. The Scala code, on the other hand, is much more verbose. It's not something you'd use as a day-to-day shell. I'm not going to open up my terminal and start writing like os.walk, pwd, blah, blah, blah. It's way too verbose. But it is much more readable, and you can probably guess what this code does, and you can guess what every step of the code does, and you'll probably guess correctly. Like, I walk the working directory, find the files, take the size, sort by the size, reverse it, take the top 3, where I get the top 3 files according to their size. So Scala, while it's not good as a replacement for the Bash shell, it can be quite a good use as a replacement for Bash scripts. And you all have seen Bash scripts that they've grown and they've become quite monstrosities that are very hard for even the most experienced engineers to manage. Maybe you rewrite them in Python, but Python has its own versions. You have different versions of Python on people's laptops. People pip install different things. So even Python is not that great for scripts. Scala, with this kind of small and kind of ergonomic libraries, has advantages over both. Like, unlike Python, you create the Scala assembly or JVM assembly jar. It runs everywhere basically the same way. You don't need to worry about the environment. And unlike Bash, you can actually read it. So there's just another example I wanted to show that is something that I actually had to do. And it is, you look at the Bash code, it's kind of gnarly. Like, who here knows why we need -cs here and we don't need -cs here? Anyone know? Or who here knows why we need to sort it before unique? Someone should know this. No one knows why? Well, yeah, so unique in Bash only works for deduplicating consecutive values. So if they're not sorted, they won't get properly deduplicated. Of course you should know that. Well, of course. So again, the Scala code is a lot more verbose than the Bash code you see on the right. But you can kind of walk through it step by step. I filter out the text files, I read it, I split it by a regex that looks like it's looking for alphanumeric characters. I group by the lowercase versions, I want to ignore case, count how many items in each group, what the length of each group is, and then I sort by the count and I reverse it to get the reverse count of all the words in my file system tree. So I personally use this a lot in my own work, where when you want to do ad hoc things and you just can't figure out the Bash command, and even Python maybe don't have the right things pip installed, in Scala you can just open up the REPL and just bang out these snippets. And it generally works with autocomplete, with type checking when you make typos, and you get nice experience to write your code. The last thing that I'm going to just skim over is that you can compile Scala to JavaScript. In fact, they are very similar languages. And if you look at these two examples, you might take you a moment to realize which side is Scala and which side is JavaScript. They look very similar. JavaScript has const, Scala has val. The lambdas look a bit different, and Scala has type annotations. But otherwise, they're very similar languages. And you can, in fact, write front ends in Scala. There are React libraries in Scala you can use. You can wrap them yourself. You can generally you can reuse any JavaScript library in Scala, just like you can reuse any Java library in Scala. So on the JVM, you can call Guava, you can call Spring, you can call Apache util. On JavaScript, you can call Moment.js, you can call React.js, you can call, I don't know what's hot nowadays, like Vue or Vite. And it generally just works. Like I can take the Scala code on the right, tuck in the browser, compile to JavaScript, and it runs the same way as you'd expect the code on the left to run, which is actually JavaScript. One surprising thing about Scala in the browser is that the performance is actually not bad. So the purple bar is JavaScript normalized to 1 for these benchmarks. The other bars are Scala compiled to JavaScript with various degrees of optimization. So Scala has a whole bunch of stuff in the back end, and there's optimizer that tries to get rid of all that stuff in order to make it fast. Like the Scala collections library, the Scala stand library, all of that doesn't exist in JavaScript. And if you left it in your JavaScript blob, you'd end up with what you see on the light blue or black lines, where it's kind of a few times slower to manage all this Scala stuff. But with the optimizer, it gets quite comparable to JavaScript. And in fact, some cases, it's even faster than handwritten JavaScript. That's also a bit of a surprise, because it turns out that handwritten JavaScript, idiomatically is not the fastest JavaScript you can write. No, the fastest JavaScript you can write is JavaScript that maps very well to like the V8 optimizer, which is somewhat different from the JavaScript that you write by hand, but is quite easily generated by the Scala optimizer that outputs JavaScript automatically, so you don't need to write it. And that's why I see in, for example, the ray tracing benchmark on the far right. The Scala code actually runs faster than handwritten JavaScript when compiled to JavaScript running in the browser. So in conclusion, like, why is Scala interesting as a language? It's a niche language, maybe 2-3% of the programming community, 15th instead of first or second or third in the language rankings. But why it's interesting is that it lets you replace a lot of other languages you may be writing with a small number of languages. So I've already showed how you can replace like JavaScript, you can replace your scripting languages like Python or Ruby. You can use it to substitute your compiled languages like Go or Java. And there's some cases I haven't shown where you can use Scala to replace, for example, HTML templates. You can use similar to what React.js has, or you can use Scala to replace SQL queries, similar to what Spark does with Spark SQL and Spark RDDs. So there are some cases where you can't use Scala yet, like you can't use Scala to replace C++ high performance stuff. You can't use Scala on iOS or on Android very well yet. But in general, it still lets you consolidate a bunch of different languages into a small number of languages. So rather than having your Python profiler and type checker, your Java profiler and type checker, your JavaScript profiler and type checker, and all sorts of other things, your bash, or what was it called, shell lint or shell check in order to try and type check your bash commands. You can kind of consolidate it under a smaller tool chain that's easier to maintain and more easy for your team, especially small teams to learn. Like if you have 100 people, 20 people per language is fine. If you have one person writing kind of a big system on their own, having one language that one person works in is a huge advantage over having to juggle 5 different languages. So yeah, that's the wrap up for this talk. You have Scala. It's a compiled language that kind of feels dynamic, and it lets you scale from small, like one-line bash commands or Python snippets to even pretty large systems like Apache Spark, million lines of code, all written in the same language without needing the rewrite. You don't have that write in bash, rewrite in Python, rewrite in Java later that you have using traditional languages. It fits into any existing JVM system, so you can reuse your tools, libraries, your kit, JProfiler, Eclipse, IntelliJ, it all works. And can consolidate a bunch of different languages into just one. And if you want to learn more, like I wrote a book on this, Hands-on Scala Programming, it teaches you how to write Scala. And if you're curious, you can go check it out. And I think that's it. Thank you.